In question number 16, we want to find the time taken by sunlight to pass the window of thickness 4 millimeters and with refractive index 1.5. Here, the speed of light through this window will be 3 into 10 power 8 divided by 1.5, that will be 2 into 10 power 8 meter per second. So the time taken is equals to thickness upon speed, that is 4 into 10 power minus 3 divided by 2 into 10 power 8. So time taken will be 2 into 10 power minus 11 second. So option 3 is correct option. In question number 17, the wavelength of the light in air is 7200 angstrom. We want to find the wavelength of light in glass, given refractive index of glass is 1.5. The refractive index is given by n is equals to c upon v. C can be written as f lambda air upon f lambda glass. Here frequency of given light will not change from medium to medium. So wavelength in glass will be equal to 7200 angstrom divided by 1.5. That will give us the answer 4800 angstrom. So option 2 is correct option. In question number 18, the refractive index of diamond is 2.4. We want to find the velocity of light in diamond. Refractive index n is equals to c by v. So v will be equal to c by n. That is 3 into 10 power 8 divided by 2.4. Simplify this, we will get v is equals to 1.25 into 10 power 8 meter per second. So option 3 is correct option. In question number 19, it is given that the reflected and refracted rays are perpendicular to each other and the angle of incidence is 60 degree. Let's say this is incident ray 60 degree, the reflected ray will be also at 60 degree and the refracted ray is perpendicular. If this angle is 60, then this angle will be 30 degree, this angle will be 60 degree, so angle of refraction will be 30 degree. Applying the Snell's law, the sine 60 degree is equals to mu sine 30 degree. So root 3 is equals to mu. So option 4 is correct option. In question number 20, we want to find the height up to which the water should be filled into a vessel of total height of 21 centimeter such that it appears half filled when viewed from the above. Here the refractive index of water is given, mu is equals to 4 by 3. Here if it is filled up to h height, then the remaining part will be 21 minus h centimeter. The same length should be appear to be filled, so apparent depth will also be 21 minus h centimeter. The refractive index is given by real depth upon apparent depth. It is given 4 by 3 is equals to real depth is h and it is appeared to be filled up to height 21 minus h centimeter. Simplify this for the value of h, we will get h is equals to 12 centimeter. So option 3 is correct option. In question number 21, the observer is observing this object from this point. We want to find the shift for the given object. Here shift will be due to this 2 medium, so total shift will be shift due to this medium will be x into 1 minus mu 3 by mu 2 plus shift due to this medium will be x into 1 minus mu 3 by mu 1. So option 1 is correct option. In question number 22, we want to find the thickness of a transparent plastic plate which will produce a change in optical path equal to the wavelength. Here change in optical path will be mu minus 1 into t, where t is the thickness of the slab and it should be equal to lambda. So the thickness will be lambda upon mu minus 1. So option 1 is correct option. In question number 23, a bird in air is at a height of y from the surface of water and a fish is at depth x below the surface of water. The refractive index of water is mu. We want to find the apparent distance of fish with respect to bird. Here we have to find this apparent depth. Apparent depth is equals to real depth upon refractive index. Here real depth is x upon mu. So total distance of fish from the bird will be y plus x upon mu. So option 3 is correct option. In question number 24, a bird in air is at height y from the surface of water. A fish is at depth x below the surface of water. The refractive index of water is mu. We want to find the apparent distance of bird from the fish. For that, first we have to find this apparent height. The apparent height is equals to real height into refractive index. Real height is y, so into mu. So total distance of bird from the fish appearing to the fish will be this distance x plus y into mu. So option 1 is correct option. In question number 25, a small air bubble is inside a transparent solid cube at exact center. The side of solid cube is A, so the air bubble will be at distance A by 2 from any surface. We want to find the apparent distance of air bubble. The apparent depth is equals to real depth upon refractive index, that is mu. So apparent depth will be equal to, your real depth is A by 2, so apparent depth will be A upon 2 mu. So option 1 is correct option. In question number 26, one side of a glass slab is silvered as shown in figure. A ray of light is incident on the other side at angle of incidence 45 degree. The refractive index of glass is given 1.5. We want to find the deviation of the ray of light from its initial path. This is the incident ray and let's say this is the finally reflected ray. We want to find the angle between these two light rays. Here let's say angle of refraction is r. If this angle is r, then this angle will also be r. This will be angle of incidence at the mirror, so angle of reflection will also be r. So on the same side the angle of incidence will be r. From this pair we can write, if at this point angle of incidence is r, then this angle will be 45 degree. So angle between the incident ray and finally refracted ray will be 90 degree. So option 3 is correct option. In question number 27, the velocity of light in air is 3 into 10 power 8 meter per second. So its refractive index will be 1, and the velocity of light in another medium is 2 into 10 power 8 meter per second. So its refractive index will be 1.5. We want to find the critical angle for the pair. Here this medium is denser and this medium is rarer. If light ray moves from denser to rarer, we can find the critical angle, that is sin IC is equals to n rarer upon n denser. So sin IC will be, here rarer medium is air, so 1 upon 3 by 2, that will be 2 by 3. So IC is equals to sin inverse 2 by 3. So option 1 is correct option. In question number 28, a ray of light traveling in a transparent medium, let's say of refractive index mu, is incident at angle of incidence 45 degree. The ray undergoes the total internal reflection. Mu is the refractive index of medium with respect to air. We want to find the possible values of mu. If 45 degree is the critical angle, then sin 45 degree will be equal to 1 by mu. So 1 by root 2 is equals to 1 by mu. So mu is equals to root 2, that is 1.4. But it is not incident at critical angle. The ray is going total internal reflection. So mu must be greater than 1.4. So the appropriate option is mu is equals to 1.5. So option 3 is correct option. In question number 29, we want to find the radius of the outer aperture that a fish underwater at depth of 20 centimeter can see. Let's say fish is at this point at the depth of 20 centimeter. If fish is looking the outer aperture as circular horizon, then at this point this angle will be critical angle. Light ray will be incidenting at critical angle. Given critical angle is 45 degree. If this angle is 45, then this angle will also be 45 degree, and this will be the radius of the aperture. From this we can write tan 45 degree is equals to r divided by 20 is equals to 1. So r is equals to 20 centimeter. Option 2 is correct option. In question number 30, we want to find the critical angle for the light going from a medium in which wavelength is 4000 angstrom to the other medium in which wavelength is 6000 angstrom. Sin IC will be lambda 1 by lambda 2. So sin IC will be 4000 angstrom divided by 6000 angstrom. So IC will be equal to sin inverse 2 by 3. So option 4 is correct option.